If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are building concept on limit for intermediate and advanced level. So we will see some shortcuts of limits and we will see indeterminate form and L'Hopital rule and what is the meaning of infinity. Okay, then let's see this. Okay, so we will see now limits for intermediate and advanced level. So we have seen, so far we have seen this last formula where if you put x equal to 0 or if you put that limit, you find this expression is coming out something like a 1 to the power infinity format. So for 1 to the power infinity format, something of this format, one example, there is always a shortcut and this is very useful. Otherwise what we do generally to solve this one, we take log both sides to bring this one down. So this, because x is on the top of x, so you have to bring it down and then you take the limit and at the end you will again remove the log, but it will take some time in the exam, so you remove this, you remember this shortcut. Suppose limit x tends to 0 fx is not 1, any value, or it should be 1, because suppose something of this format I am saying, limit x tends to 0, x tends to fx to the power gx, phi x, so fx is 1, this is infinity, so it is 1 to the power infinity format. So here this is fx, this is your gx, so the format is always e to the power limit power into base minus 1. Power is this one into base minus 1. Suppose base to the power, it is of this format. If you put that limit, it is becoming 1 and infinity. So the idea is e to the power limit, whatever limit they have given, then power into base minus 1. You can remember also this one, power into base minus 1, and limit will be there. So if you put this one, you will get this answer. That is your E. In this case, it is E. It is direct formula, or other questions also you will find this one. Now there are 7 indeterminate form I told you, so that is also important, which is known as L'Hopital rules. These formats I have no answer till now. All other values, suppose you can say 1 to the power infinity is 0, something to the power infinity is 0. So all other formats are okay, you have answer. 0 to the power infinity also you have answer 0. But infinity to the power 0 you don't have, because infinity is not a number, it's a notion. Its notion means it is giving indication that number is going to be huge, very large. It is not a number. 0 by 0 is undefined, infinity by infinity is undefined. These two are standard in divide, you can remember. 0 infinity, because infinity is not a number, so you don't know if you multiply with 0, what it will be. 0 into any number is 0, but infinity is not a number, you have to be careful. 0 to the power 0, again not defined. Infinity to the power 0, again something number to the power 0 is 0, 1, but infinity is not a number, you have to be again careful. Number minus number is always 0, but infinity is not a number, so you cannot say. But infinity plus infinity you can say, because infinity is giving a notion of huge number. So huge number plus huge number will be also huge number. But huge number minus huge number, you don't say it can be 0, because huge number can be, these two huge numbers can be different. And 1 to the power into 1 to the power, again it is not a number, normal number. 1 to the power any number is 1, but infinity is not a number. So if you put limits, suppose this one, sin x by x, if you put x, see what is the format, 0 by 0, sin x is sin 0 is 0 x, so it is 0 by 0 format, means suppose you don't know formula, so it will go to indeterminate format. So for any of these indeterminate format, 7, 1, 2, 3, 4, 5, 6, 7, you can apply L'Hopital rule. Sometimes it is say L'Hopital rule or Hopital rule, this S is silent. So it can be applied. What is this rule? This rule says you should have numerator denominator format. Even if you don't have, you have to create numerator denominator. Otherwise, without this format, you cannot apply this. Suppose you have this format or you have created this format, then the idea is you differentiate the upper one separately, you differentiate the lower one separately, one time. Then you check. If you again put limit x tends to 0, see whether this indeterminate format is vanished or not. If you again get that same indeterminate format or any other indeterminate format, then you again differentiate it. Double derivative of upper one, it is not u by v. Simply differentiation of this one separate, differentiation of numerator separate and denominator separately. One more time. Again check. So you continue this one until your indeterminate form vanishes. Once it vanishes, then you can directly put that value, you will get that answer. Now that was the thing I was talking about infinity. We cannot plot infinity on the paper, because infinity is a symbol, it's not a number, it's a notion, it's an idea, it's not a number. It doesn't obey the laws of elementary algebra, so it's not going to obey all your algebra that you have learned. So you see the notion, from the notion you can say big number plus big number will be a big number, big number into big number will be a big number, something divided by very big number will be goes to 0. if A is a finite, we have to be, because 0 by infinity is 0 by something is always 0, you know, but 0 by some number it is if A is 0, then 0 by infinity is undefined, is not defined, that is not in indeterminate form, so that is undefined. Suppose you have a product of two numbers is 0, so either A is 0 or B 0 or AB both 0, that can be possible, but AB both should be finite. If one is infinity, then it is not possible. You can see 0 into infinity is undefined, so if one becomes infinite, then it is not true. So that's why it is written AB both should be finite. One can be 0, this can be 0, both can be 0, but both should have finite. 0 is a finite value. One cannot go to infinite by infinity. If you like the video, then press the like button and please give your valuable comments in the comment section.